the second planet from the Sun, almost the same size as Earth. For a long time, scientists believed that beneath its white clouds, Venus might hide a tropical paradise, perhaps oceans, steamy jungles, even life. But the truth turned out to be far more severe. Beneath those clouds lies not paradise, but a true hell, an atmosphere you can't breathe, temperatures hot enough to melt lead, pressure comparable to the deep ocean, and clouds filled with sulfuric acid. Today, we journey to Venus, a twin planet that could have become a second Earth, but turned into something terrifying. Why did that happen? What do we know? And most importantly, what can Venus teach us about the future of our own planet? Venus and Earth? Twins? At first glance, Venus and Earth really do look like twins. Venus has a diameter of 12,104 kilometers, just 650 kilometers less than Earth's. Their mass, density, and surface gravity are remarkably similar. Gravity on Venus is about 90% of Earth's. That means a person would feel almost the same weight standing there. The gravitational acceleration is 8.87 meters per second squared. But here's where the similarities end. Venus rotates extremely slowly, and in the opposite direction to most other planets. One day on Venus lasts 243 Earth days, while its year is only 225 days long. That means a single day on Venus is longer than its year. Moreover, Venus has almost no axial tilt, just 3 degrees. This means it experiences virtually no seasons. Venus' atmosphere is composed mostly of carbon dioxide, over 96.5%. The rest is nitrogen, with traces of sulfur dioxide, argon, water vapor, and other gases. Even in small amounts, these compounds play a huge role in shaping the climate. Surface pressure is about 92 bars. That's like being 900 meters underwater on Earth. The surface temperature is around 465 degrees Celsius, hotter than Mercury, even though Venus is farther from the Sun. The reason? A runaway greenhouse effect caused by its thick CO2 atmosphere. Venusian clouds are found between 45 and 70 kilometers in altitude. They're made of concentrated sulfuric acid and tiny acid droplets. These clouds reflect about 75% of the sunlight, making Venus incredibly bright in Earth's sky. That's why it's known as the morning star or evening star. Once, long ago, Venus may have had an Earth-like atmosphere and water on its surface. Climate models suggest that shallow oceans or lakes may have existed. But about 700 million years ago, everything changed. Being closer to the Sun, Venus received more solar energy. Water began to evaporate. Water vapor, like CO2, is a potent greenhouse gas. The temperature rose, causing even more evaporation. Ultraviolet radiation from the Sun split water molecules in the upper atmosphere. Light hydrogen escaped into space, while heavier oxygen either drifted away or reacted with rocks. Water was lost. CO2 remained. The greenhouse effect spiraled out of control. Today, we call this the runaway greenhouse effect, a self-reinforcing feedback loop where warming leads to more warming. This theory is supported by both climate simulations and geochemical data. Some scientists also believe massive volcanic eruptions may have accelerated this transformation. Most of Venus's surface is covered by solidified lava flows. Radar images from the Magellan spacecraft revealed flat plains crossed by thousands of volcanoes. Scientists estimate that there may be over 1,600 major volcanoes, and perhaps hundreds of thousands of smaller ones. Research suggests that large parts of the surface may have been resurfaced less than 500 million years ago. This could point to a planet-wide volcanic event or episodic releases of internal heat. Unique structures known as coronae are found on Venus, huge ring-shaped formations hundreds of kilometers wide. They're formed by upwellings of hot mantle material. There are also ridges, faults, shield volcanoes, and possible lava tubes. Maxwell Montes, the highest point on Venus, rises 11 kilometers above the mean surface level, higher than Mount Everest. The first detailed studies of Venus came from the Soviet Venera program. Venera 7 became the first spacecraft to transmit data from the surface of another planet. It operated for 23 minutes. Venera 9 and 10 sent back the first black and white photos. In 1982, Venera 13 returned the first color images and even audio recordings. It lasted 127 minutes in the extreme heat and pressure. These were engineering marvels. Designed with thick pressure vessels, active cooling systems, and protective shielding, but survival was always brief. NASA's Pioneer Venus missions also contributed valuable atmospheric data. However, no Western spacecraft has ever landed on Venus's surface. Venus is not just a planetary hellscape. It's a vital scientific laboratory. First, it helps us understand climate dynamics, especially the power and danger of the greenhouse effect. It shows how delicate a planet's atmosphere can be. Second, Venus serves as a comparison for exoplanets. Many newly discovered planets orbit close to their stars and have dense atmospheres. These super-Venuses might be common. There are also provocative questions about life. Some scientists speculate that microbial life could survive in the upper cloud layers, where temperatures and pressures are much more Earth-like. The idea is controversial, but it's led to exciting mission proposals. On the surface, life is impossible. It's too hot, too toxic, and under crushing pressure. But 50 to 60 kilometers above the surface, conditions change dramatically. Temperatures hover around 20 degrees Celsius. Atmospheric pressure is similar to Earth. That's why NASA has proposed floating habitats. The HAVOC concept, High-Altitude Venus Operational Concept, imagines blimp-like stations drifting in the upper atmosphere. Upcoming missions include Veritas, NASA, an orbital radar mission to study surface geology, Da Vinci Plus, a probe that will descend through the atmosphere to the surface, and Vision, ESA, a high-resolution orbiter with radar and spectrometers. These missions will help answer key questions. Did Venus ever have oceans? Could it have supported life? Why did it evolve so differently from Earth? Venus is a planetary warning. It reminds us that nature's balance is fragile, that looking similar doesn't mean behaving similarly, and that even planets starting out alike can take radically different paths. Venus was almost like Earth, but it became the most hostile planet in the solar system. That's why we continue to look at it, to study, to learn, and perhaps to better protect our own world. Thank you for joining us on this journey. Subscribe if you'd like to explore more of the cosmos. Until next time.